Hello everyone and welcome to our channel CodeChef. Today we'll be solving the problem find the pattern, the difficulty level of simple. This is a special problem statement that states that we need to figure out the logic from the given sample input and output and use that logic to solve the problem. First line contains a number of test cases and second line contains a value v. If you're wondering about the constraints on v can range from basically 1 to 1000. Now let's move on to the sample cases. We know that we have 8 test cases and these are the 8 test cases. Each test case is basically a number and we also have the output corresponding to each of the 8 test cases. We are supposed to find the relation between the input and output. Now we know for the input 10, the output has to be 8. For the input 30, the output basically has to be 42. And for the input 45, the output has to be 33. So on, so on. But let's try to figure out the relation using these 3 examples that we have. What if for the input n equal to 10, let's list down all the factors. The factors of 10 are 1, 2, 5 and 10. But if you take the sum of this, you get 18. So, but what you have here is 8. So what if you take the sum of all the factors of n, but excluding the number n itself? In that case, what you get is 1 plus 2 plus 5, that is equal to 8. So it matches for the first test case. But is this the correct logic? Let's figure it out for n equal to 30. List down all the factors of 30. You get 1, you get 2, you get 3, 5, 6, 10, 15 and 30. I think these are all the factors. Remember, we are supposed to find the sum till here and we're not going to include number n itself. So when you do this, you get 3, 6, 11, 17, 27 and 42. So 42, it seems to be working. Let's for good measure try it for n equal to 45 also. List down all the factors of the input. That is 1, 2 is not a factor, 3 is a factor, 5 is a factor, 9, 15 and 45. Now remember, we are finding the sum here excluding the number n itself. That is 4, 9, 18 and 33. So you look at this works. So the problem statement is nothing but take the input, list down the factors, find the sum of the factors excluding the number n itself and output that. Now let's look at the approach. Basically, we know that the problem statement boils down to finding out the sum of factors of a given number n. We however need to handle the condition that we need to exclude n from our sum. Let's look at different ways we can find the sum of factors. Let's look at the brute force O of n approach, which is enough to pass the time limit of this problem because n is very small. N can only go up to 1000 in this problem. But we'll also look at other cases so that you're familiar with other techniques also. The first brute force technique is very simple. We just run a loop from I is 1 till I is n and we check at each iteration if n mod I equal to 0. Meaning that if n mod I equal to 0, I is a factor because when you divide n with I, the remainder was 0. Since I is a factor, you do sum equal to sum plus I. At the end, if you want to exclude n from the sum, a simple way is after you find out the sum including n, you just do sum equal to sum minus n. This is one simple way of excluding n from your sum. Now let's look at this is O of n. Now let's look at the O of root n approach. What this basically uses is if I is a factor and then the other factor corresponding to I in order to make n is nothing but n by I. This observation is what is used by this approach, that if you have I which you know is a factor, n by I is another factor. However, in this case you need to handle a tricky case where n is, let's say, 36 and you found 6 as a factor. If n is 36 and 6 is a factor, you know that the other factor has to be n by I, that is 36 by 6, that is again 6. But you don't want to add 2 6s to your sum. Your sum should add only 1 6. So to handle that special condition, we need to add an if condition. That's all is the approach. So what we do is we run a loop from I is 1 till root n. Then we check if n mod I equal to 0, which is the same condition as the previous case. I is a factor if this condition is satisfied. We do sum equal to sum plus I. Then we check if n by I is a different factor than I. If n by I is a different factor than I, we do sum equal to sum plus n by I. Let's just dry run it for a small case like 30. Now root of 30 is basically approximately 5 because 5 square is 25 and 6 square is 36. So let's say that the integer version of the square root is 5. The running loop from 1 till 5. So what we'll check is we'll check if 30 is divisible by 1. This is true. So this is a factor corresponding to 1, you get 30. So 30 is another factor and you'll add 30 to your sum. Then you check for 2. 2 is a factor of 30. Yes. So corresponding to 2, you'll also get 15 as a factor. Then you check for 3. Corresponding to 3, what you will get as a factor? You will get 10 because 30 by 3 is 10. You check for 4, but 4 is not a factor. Then you check for 5. Corresponding to 5, you will get 6. So your sum will be 1 plus 30 plus 2 plus 15 plus 3 plus 10 plus 5 plus 6. And at the end, like we discussed, you can just add this condition to exclude n from your sum. So you can just do sum minus equal to n at the end to get the sum excluding n. This was the other approach, that was root n. So it is more efficient than the previous approach. Let's look at the prime factorization approach to find the sum of factors. Let's say you have this number 30. What we do is we find the prime factorization of 30, that is 2 power 1 into 3 power 1 into 5 power 1. Basically, which means that 2 into 3 is 6, 6 into 5 is 30. This is the prime factorization. After you get the prime factorization, in order to get the sum of factors, what you do is take 2, put 2 as it is, then raise this power by 1. So increment this power whatever it is by 1. So it was 2 power 1. So this became 2 power 2. Minus 1 by 2 minus 1. So normally let's say that you have something like a, let's say you have p power a, where p is a prime number and a is a power to which a prime number is raised in the prime factorization. This approach is nothing but p of a plus 1 minus 1 by p minus 1. You'll multiply the products in this format. So p is a prime number and a is a power. So in this case 3 is a prime number and 1 is a power. So if you follow this, what will you get? P power a plus 1 minus 1 by p minus 1. That is 3 square minus 1 by 3 minus 1. Similarly 5 power 1 you have here. So it's 5 square minus 1 by 5 minus 1. You find the product of all these, and what will it be in this case? Let me just write it here. 2 square minus 1 is nothing but 4 minus 1, that is 3. Now 2 minus 1 is just 1. Now if you do 3 square minus 1, you get nothing but 9 minus 1, that is 8. And when you do 3 minus 1 here in the denominator, what you get is nothing but 2. When you do 5 square minus 1, you get 25 minus 1, that is 24. And then when you do 5 minus 1, what you get is nothing but 4. So when you take this product, you get 4 here, you get 6 here. So 3 into 4 is 12, 12 into 6 is 72. So we get that the sum of all the factors of 30 is 72. But we know we need to exclude n from the sum. So you do 72 minus 30 and get 42 as our answer. Hope this approach is also clear. You can also, if you don't want to do this part here, you can also handle it in other ways. Like the simplest way in the brute force approach is just run a loop till less than n. So this is also one way to exclude n. I hope all these are clear. Now let's look at a few mistakes to avoid. I've taken this submission from the submissions page, and what they're doing is they're taking the number of test cases as input, and then for every test case they take number as input. They set sum is 1, and then they run a loop from 2 till less than number, and they check if number mod I equal to 0. If this is satisfied, they do sum equal to sum plus I, and then they print sum. Now this looks exactly correct to what we've discussed. However, even if we check it for a number like 30, this will give the correct output, and I'll prove it to you. When a number is 30, what happens is sum is initialized to 1. So sum is 1 first, and then they run a loop from 2 till less than number. So from 2 to 29, they check if each I is a factor or not. So which numbers will cause this condition to be true? Basically 2, 3, 5, 6, 10, 15. Or for all these numbers, this condition will be satisfied. For all these I numbers, the condition will be satisfied because these are all the factors. The sum is basically sum equal to sum plus I whenever the condition is satisfied. Sum was initially 1. So sum became 3, sum became 6, sum became 11, 17, 27 and 42. So they output 42, which is correct. Then you might ask, what is wrong in the submission? So everything looks perfect. Now we are missing a case where you know that numbers range is between 1 and 1000. What if number is basically 1? What if the input is basically 1? When the input is 1, what the output is supposed to be is 0. Because we are supposed to find out the sum of factors of number excluding n, or the number itself. 1 has only one factor, that is itself. So when you exclude itself, the output has to be 0. However, in this approach, since we are pre-initializing sum to 1, this approach will give sum as 1. For number is 1. Let's look at the code for this problem. First, let's look at the C++ code. For every test case, we take n as input, and then we have a variable sum equal to 0. Then we run a loop for I equal to 1, I less than equal to the root of n, I plus plus. And then if n mod I equal to 0, we know I is a factor, and so we do sum equal to sum plus I. Then we check if n by I not equal to I, denoting that n by I is another distinct factor that needs to be added to the sum, and so we do sum plus equal to n by I. At the end, we need to exclude n from our sum, so we just output sum minus n. Let's submit this solution in C++ and see if we get an AC. Remember, the time complexity for this solution is for every test case, it is root n, and we get an AC here. Let's move on to Python. In Python, I've written the brute force approach, which is for every test case, we take n as input, and then we have answer or sum equal to 0, and then we run a loop for I in range 1 to n. In Python, the range function is exclusive in the sense that if you have for I in range 1 to 3, only numbers 1 and 2 will be processed. So the second parameter is exclusive and the first parameter is inclusive. So this is effectively running a loop for I equal to 1 till I less than equal to n minus 1. Effectively, that's what this does. Then we check if n mod I equal to 0. Then if that is satisfied, we do answer equal to answer plus I, and at the end we print answer. Now remember, we don't do answer equal to answer minus n because we've already excluded n in this for loop. This for loop starts at 1 and ends at n minus 1. This complexity for every test case is O of n, and we get an AC in Python. Hey guys, that was it. Thank you so much for watching this video, and if you haven't yet done this, this is a gentle reminder to hit that subscribe button. If you're interested in competitive programming and data structures, this channel is a one-stop solution for you. See you in the next video. Bye.